Oh, hey, it's working. Hey, y'all. Calculators at the ready. Plug in this model. We're on 2.14 part B, example 8. Chimney crickets. Oh, was it last time I did this that things went wild?
Yes.
Oh, okay. This one will probably be an unlisted video. Do you guys remember how to plug this in? If you plan on taking AP Stats, get used to using a lot of calculators.
It's gonna be the last time I see you. When I'm gonna graduate. I'm just gonna leave.
Me too. Let me know if I plug something in wrong. It's a lot harder for me to plug it in on this thing because it lags. All right, let's see. Do y'all think we could find this equation? Let's say you forgot, like, which regression to use. Let's see if we can figure it out. I'm going to hit stat, calculate, right? Which one do you think we should use? Which one should we use? Which one should we use? Do we want to use natural log or regular log? You want to use natural log reg or logarithmic reg? All right, let's see what happens. Are you sure that that's log? You guys don't want to do B?
Well, the x's are going up by like 1. That's log.
All right. Do we need a frequency list?
No.
I don't know. What did I do wrong?
Which one did you put?
The wrong one, I think.
Which one's the wrong one?
I don't remember how to do this. Yep. It is the ln reg one. ln reg. So get used to it. If you see this and you need a regression function, you're going to do the same thing. Now, if it's quadratic or logarithmic or exponential or linear, I don't know if at the end they'll tell you which one it is. You might have to figure it out. But this one, so far most of the questions I've seen, they tell you, find the logarithmic regression, find the exponential. So my equation is negative 2.6463. And that'd be a minus, right? Wait, is it? There it is. It'd be a plus 4.6542 natural log of x. Where did we just see an equation like that? Life expectancy, right?
Oh yeah.
Why would life expectancy be a log equation? Because remember, logs look like this, right? And that's life expectancy. There's going to be almost like a line. Like humans are only designed to go so far currently. Yeah. All right. What happens when x is 10? What would I do with that? Plug in 10. Oh no, who shut my key? What did you guys get? What am I doing? Who am I?
Take a wild guess.
Ooh, I could take a wild guess.
I'd say 6.8. Hot takes. That's wrong takes.
Hot cakes.
Wait, no, 8.5.
You think 8.5?
Okay.
8.1. 8.1. Oh, I should have plugged in a 10 here, right? Because it's f of 10. And it's approximately 8.1. Yeah. Read the question. Now, what is a residual? We haven't talked about this yet. It's time we talk about it. The residual Is this equation 100% exact? It's a estimate, right? So residual is how far is our estimate from reality. Okay? So we usually call this y hat. Ooh, flashbacks. Like we'd call this y hat. That's an estimate, y hat. Honestly, for those Utes in AP Pre-Calc, AP Stats is going to be actually a lot easier if you take it once we get through this. Because you already know residuals and your regressions. All right, so what we do for residual is we're going to do y minus y hat. Y is my real, y hat is my estimate. So now they gave me the point. This is real. That's real. That's on the graph, right? How would I find an estimate for 4? I plug it in, right? When I plug in 4, I get 3.8. We'll just do 3.8. So that's my estimate. Estimate based on my equation. I plug in 4, get an estimate. But I know my real is 4.5. So what's my residual? What's the difference between my estimate and my real? We'll do more with that when we get really close to the test. I say that for the end because it overlaps with stats. Yeah.
You just plug in 4. But up here, it's 4.
Next week. All right. Here's what I want you all to try. Here's what I want you to try. Maybe. Oh no, you guys don't know how to do this yet.
This is lin reg.
I want you to do example 9, A and B. But I want you to find a partner, someone to help you out through it. And I want one person to do A and one person to be B. And keep your data up there. Sound good? So do example 9 and find a partner. Those of you, my homies online, you're on your own. Have one person do A and one person do B. Do. Intermission. Wait, I can pause the video, I guess.
No, leave it on time.
We're back. All right, let's do this. What do y'all get for the logarithmic function? Someone help me out. Does anyone disagree with that when you guys get? That's good. Now, I need to look this up. You should also have gotten an R with it that said 0.99.
Oh, you should get that.
Do you guys remember that? I'll teach you guys how to do that in your settings. But what R means, the closer to 1 means it's a better fit. Okay? What do you guys get for the linear regression model? And when you did that, you should have gotten R is 0.96. I'm gonna look into it, make sure we get them all. Now, so let's say this is important. I'll wait. We need to get eyes up here. So let's say they give you data and you don't know if it's a logarithm or linear or quadratic. Did you have to re-enter in your stats to do both these tests? Once I get the R's, the closer the R is to 1, the more accurate it is. So which one's going to be more accurate? My logarithm or my linear? Log. Log. Has a bigger R. Okay. I'll look into it. I'll get you guys hooked up. Write a note to myself. Closest to 1. Oh, they can.
So
No, they can't. Not with R. That's correlation coefficient. Yeah, you can have a negative. You can have a negative R. Negative 0.99 is better than 9.96. You'll see that. That's not going to come up here, though. Not going to come up here. In AP Stats, we do. All right, what's the best model to use it when f of x equals 8, then? Well, which one's better for the logs one, right? So it's not telling us to solve it. Do I need to scroll up for you guys? Yeah, probably. Explain the meaning of life in context.
I mean, we have to write some words.
You guys want the answer to the meaning of life?
42.
42. I believe your meaning of life is that which you leave behind when you're off this plane of existence. All right. What's it mean when f of x is 8?
Your time is 8 minutes.
Oh, they do want us to answer. All right. When I do this, no, it tells me when will the boat, this is when the boat is going 8 what hot dogs? 8 meters per second. Because what was my x in the problem? My x is time, right? My f of x is speed of the boot. If you forget, look. If you ever look at example 9, look at your chart. Do you see how like it says speed? That's your y. Everything in y is speed. So when you have f of x equals, that means your speed is 8 meters per second. If you want to know the answer, it would be 12.48 minutes. So it takes 12.48 minutes to go 8 meters per second. What's your question?
Oh, it's when f of x.
Yes, when does f of x...
I thought it was when
You're not plugging in 8. It's saying when does it equal 8?
I thought x.
All right, let's do a free response question that you would see on the test. There are 2 free response questions on it. Well, it's a 2-day test. 2-day test. 2-day test. Stop sleeping. All right. Let's read it first. They're doing a study on drinks that are caffeinated to see if it affected or when it affected their bloodstreams. We need to come up with an equation for it. Do you guys mind if how confident do y'all feel that you can do this in your calculator? Yeah, give me a confidence interval. So would you agree that we can plug this in our calculator and get f of x equals 40.801 minus 7.214 natural log of x? Do you guys feel good about that?
Yeah, I agree with that.
Now, some big questions I want to ask myself. Which is my x and which is my y, though? We have time and we have level of caffeine. What are we affecting in this lab? What are we changing? So that makes it our x. Because that's our independent. That's what we control. Right? And then what are we measuring? The amount of caffeine. Be consistent, Mr. Twilliger. All right, we good on that? Yeah. If you really wanted to be cool, if you want, some people do this. If you want to make your life easier, and I say this in stats too, could I actually write this as f of like milligrams of caffeine, equals like I could plug in instead of the letter, you know what I mean? Like, and I could even write that's my hours, you know what I mean? Hours equals f of my milligrams caffeine. You know what I mean? In stats, a lot of times we do just write out the words that they are in the equation because it makes it easier to go back and answer questions on it, right? By all means, you can do that. Write this equation, though they want a logarithmic regressive function, but you can write it somewhere with the words in it that it is. All right. Let's answer these questions now. Good, the equations say. Find the time it takes for the average person to metabolize 50% of their caffeine in their bloodstream. How much caffeine are we starting with according to this equation? So what do I need to set the equation, or what am I plugging into the equation? What do I plug into the equation? No, like just in words, what am I plugging into my equations? What is X? What's my X? Milligrams caffeine. So what do I plug in for X? 125. This is why this one's different. Sometimes, usually my X is time, but this one it's caffeine is my X. I'm plugging in 125 because that's half of 250. All right. So again, label your stuff. It makes life easier. Label, stop and think sometimes. Oopsie. Okay. I'm not plugging in time on this one. I'm plugging in my caffeine levels. Because what do I want? I want time, and time was my Y. I got F of 125 is 5.969 hours. Now, am I going to get credit for this? No, because I didn't put my name on my paper. No. What would I have to say? Round to the nearest tenth. What would this round to?
6 hours.
6. So I could write this a lot of ways. I could say to reach 125 milligrams, it would take 6 hours. I could say it takes about 6 hours to metabolize. Yeah, go back. If you don't know how to word it, go back and read the question. You know what I mean? You could word it differently, but it's easier just to use their verbiage, right? To metabolize 50% of the caffeine. That's wild. Because that's true. The half-life of caffeine is 6 hours, if you look into it. That's why the 2 p.m. crash. All right, Avery drank an energy drink containing, Haley drank a Celsius that has 250 milligrams of caffeine. I think they're pretty close to that, actually. 200, so even less. At 9 a.m., around 9, look at this. This is almost perfect. How much caffeine will be in their bloodstream after 10 hours later? We have to use 250 because what's our equation? This is for starting with 250, right? That's what we started with. So how would I do it? What do I plug in my caffeine or do I plug in hours? What's my X and which one's my X and which is my Y? Time is Y. So that means I set it equal to 10 hours, right? That's why I said this one was tricky because they flipped what X and Y usually is. Because they hate us. They hate us because they ain't us, right? That was a common expression back in my day. Does that make sense what I did there, though? We have to solve for it.
Yeah.
2005.
I was instead of freshman in college.
You guys were just zygotes. All right. No. And some of you still are. All right, so, oopsie. So let's solve it. Oh, they just did it on the calculator and solved it and did the graph. Do you guys mind if I super speed a little bit? If you saw this, do you guys feel confident you could solve it? Subtract, divide, E. Subtract, it was like the warm-up, right? So when I did this, I got X's 71.49. They want us to round to the nearest milligram. Milligrams. Calf. All right, so what does this mean? So if we scale this down, Haley still has about 50 milligrams caffeine in her bloodstream after 10 hours. How much would be in her bloodstream at game time? Ooh, we could actually, we could actually calculate that. All right. So that tells me after 10 hours. Oh, wait. Does it ask? Oh, we could actually give it time if we want to be smooth. If we want to be smooth, we could. But after 10 hours, we expect to find 71 milligrams of caffeine. Is it IE or EI? I struggle with this one.
Whatever you feel like that day.
In blood.
It's like the word feed.
I'm a fiend hunter. It's like Garfield. I can never spell it right. Do they do grammar? They're math teachers. I only know one person who's a math and English teacher has both degrees in my life. I've only met one. Miss White. She's a double major, math and English. Middle school math, no less. I don't know. No. All right. Are we okay so far? This is a question that's just getting you guys ready to, how do I answer the questions, right? I did look it up. This is not a 50-50 split. It's like a 65-35. More of your points come from multiple choice than free response on this test. And then in the multiple choice, 2/3 are non-calculator. So what's the biggest portion is multiple choice non-calculator. All right, they said that people can't sleep unless their caffeine levels are below 70 milligrams.
So what if you can't? Oh, that's what you're not told.
That's a dangerous game you're playing, Doc. All right. So to the nearest hour, how long will the body take to metabolize to reach 750 if you drink 250?
A lot.
No, well, think about this. Milligrams of caffeine, is that my X or Y? That's my X, so I just plug in 70. Right? Let's plug in 70. And I got 10.152. Does that make sense with our previous question? Because it took 10 hours to get to 71, right? So it makes sense that'd be a little bit over 10 to get to 70. So again, this question's here just to see, do you know where to plug in the numbers? Which part are you finding? So what's this tell us? What's it wants to round to on this one? To the nearest hour. If you really wanted to sound cool, it will take, I would say a little over 10, but I'm going to say a boot. It'll take a boot 10 hours for my Canadian crew out there so you guys understand. It'll take a boot 10 hours for the caffeine. To reach 70 milligrams. How will boot that?
Drink a gram of caffeine, you would die.
A gram? Yes.
I think I can rate it.
All right. You guys do E. Give it a shot for tomorrow. I want to hear the answers. I want to hear what you guys come up with because you guys are smart, intelligent young people.
I don't know. We're gonna have